You'll notice behind me most of the rocks are really black, and some of them are full of a lot of small holes. These are all igneous rocks, volcanic rocks, because this is on what's called a volcanic hotspot. If you think about how islands form, you know, most of the time you've got a plate boundary, and because of the plate boundary, there's a bunch of magma coming up from the mantle that's creating little volcanoes that become small mountains underwater, and they get higher and higher until they break the surface of the water. Well, in a hotspot, you're in the middle of a plate, you're not by a boundary, and there's just one part of the plate that for some reason happens to be a little bit thinner than every other part of the plate. And because of that, all of that lava will be able to break through the surface into volcanoes. Those volcanoes can rise higher and higher. You'll notice I'm backing up because the ocean is coming up to me. Will rise higher and higher until they eventually make an islet. And the entire Galapagos chain is full of islands made from one hotspot that keeps moving further and further to the west. Because of that, there's newer islands in the western part of the Galapagos and older islands that were made a while ago when the hotspot was further east in the eastern part of the Galapagos. So you'll see a lot more greenery here because we're in the east. And when we visit some of the western islands, you'll see a lot more just rocky tuff and maybe a little bit of moss at the best. There's basically two ways that islands can get built. One way is around a plate boundary, and in the plate boundary, if the plates are moving apart, there's going to be magma coming up. That magma will cool into rock, and if it's underwater and it gets higher and higher and higher, eventually it becomes an island. Sometimes you also have volcanoes at plate boundaries that are going together or sideways, it just kind of depends. But the other way is something called a hotspot. So right now we're in the middle of the Pacific Plate, and the Pacific Plate is moving towards South America, basically moving eastward. As that happens, there's this spot, this really hot spot inside the plate that's there. It's basically a thin spot that magma can burst through sometimes. What you're seeing behind me is actually what used to be about 3 million years ago a giant volcanic crater. There's a huge volcano there that was there for quite a bit of time and erupting, and eventually formed all of these rock structures you see behind me. This whole entire island was formed there. And this beach, rather than being made from weathered rocks or weathered sand, is actually made primarily of volcanic ash and some of the pieces of ash that turned into rock and then settled. It's mostly an igneous beach. And that gives you the sort of like brownish tan color that you see. But because that hot spot is constantly moving, it is going to create newer and newer islands. And old islands like this one, which used to be above ground, are going to sink into the sea. And this one has been sinking a little bit every single year until eventually it'll be completely submerged. There's two forces that'll make this island end up back under the ocean where it started. One of them are these waves. Every second, every minute, every day, every year, those waves are going to batter and erode away at the sides of this island and pull them back out into the ocean, depositing them on the ocean floor. And the second force are the plates themselves. The same plate that had a hot spot that erupted, made this island, is getting pushed into the plate that South America is on right now. That plate is then going to subduct or sink underneath that plate, pushing up mountain ranges on the other side. And as those two plates converge and come together, the one that goes down and disappears, well, that's on here. And it's getting pulled in that same direction, stretched out, so the island sinks lower and lower.